In this session, we're going to review Network Address Translation, or NAT, and then we'll go through the configuration of NAT and the verification. So first, what's the purpose of NAT? Well, what NAT does is it translates private, unroutable IP addresses to public routable addresses. So as you know, that there are certain addresses in what we call the private address space that isn't routable over a public network. So it's not routable over the internet. Those are the Class A or the 10 network. Class B is 172.16 to 172.31. And Class C is the 192.168 networks, 0 to 255. So whenever I use these addresses, usually internally, a lot of you might use them in your house, in your work already, these can't go to the internet by themselves. Like, they aren't routable over the internet. You know, we use a lot of examples with them because they're really easy to set up. That way we're not using someone else's address space, but they're not routable. That's what NAT's going to do for us. If I have a host that's addressed with one of these private IP addresses, I need to use NAT in order to allow that host to get out to the internet. So why was it created? Originally to conserve address space. We were growing the internet, and the hosts and the devices that needed to be on the internet were growing at such a massive rate that the assumption was we're going to run out of address space, so what are we going to do about it? This was one solution. What it allowed us to do, or what it allowed your service provider to say, okay, you know what? You get this small subset of addresses. I'm going to give these 10 to your enterprise. Okay, and within another subnet, I'm going to give another 10. You know, rather than giving away a whole Class B or whole Class C subnet, I can just give you a few public routable addresses, and you can use those to get to the internet. So what I would do is internally, inside my LAN, I go ahead and I use private address space. 192.168 is really common, right? Use something in that space. I use that address space on the inside of my network. Whenever those hosts that are addressed with those 192.168 addresses want to go out to the internet, they're going to use NAT, and they're going to get translated to one of the public addresses, or the public address, if you only get one, that you were provided by your service provider to go out to the internet. Right, so we conserved address space by service providers not having to give huge blocks of public addresses to people, to enterprises. Then we also made our addressing in this way, maybe even possibly inadvertently, more stable. Because now if my service provider goes through, you know, and redesigns its network or changes its address space or whatever, or changes the address space it wants to give me, all I have to do is change my NAT configuration. I don't have to change the configuration on, say, my 1,000 hosts that I have inside my network, or my 5,000 hosts that I have inside my network. All I need to do is readdress just the NAT configuration portion of it. And then we get a slight, and I don't want to call this security, because those of you that are in security and work with it in depth know that there's just a slight security benefit to NAT, because my actual addresses of my hosts and servers and things like that are being hidden behind this NAT. Okay. We have three types of NAT. Static is a one-to-one mapping, oftentimes used with servers. So if I host a web server internally, I don't necessarily want that address to change. I don't want it to pull an address from the pool and have that address be different necessarily every time. So I would use static NAT in order for people to get in and use that to get to that web server and for that web server to respond. I use a dynamic NAT. Will use a whole pool of addresses and just assign those addresses dynamically. And then we have port address translation, or NAT overload. Okay. Generally the same as dynamic NAT. The biggest difference is we have to add the keyword overload at the end. So I can be given, say, one address, which is probably a lot like your house. Either you're given, let's say your service provider your house, if you're using cable. You connect your router up. Your service provider gives you one address. You can overload to that address, or you can overload to that interface. And you can have multiple hosts inside your house going out to the internet. You know, say you have yourself an Xbox One, and that's got to go to the internet. We've got all smart TVs nowadays, right? And so those all want to go out. We're all going to use, you know, some sort of movie streaming. We're all watching movies, and everybody's in their own room. But we only have that one public address. So most of you likely use NAT inside your own home networks. That could be one address, or you could get a pool of addresses. It's just that the pool of addresses, when you're using NAT overload or PAT, is smaller than the number of hosts you have inside your network. And so that's why we use the keyword overload to say go ahead and overload this address space. And so we'll go over just kind of we'll go over all three of them, the configuration, then we'll actually configure and verify. So what are the commands first? Let's look at the commands before we actually do it. The first set of commands is we need to decide which interface is the inside and which is the outside using the IPNAT inside and outside command. And it's as simple as that. And your inside interface is going to be your interface facing your local area network or facing your enterprise network, right? And the outside interface is going to be the one facing the public network or your service provider. These two commands are required for all versions of NAT, and so we put that first. And then we have static NAT. So once we define inside and outside with static NAT, then we just need to define the static mapping. The IPNAT inside source static, inside local address, that's my private address, okay, of the device. So if I have a server that's assigned an address of 200.1.1.5, I'm sorry, private. I gotta have a server that is assigned an address of 192.168.1.10. That's my inside local address. My inside global address is the public address as my inside, as we know about it, that my inside local address would be translated to. So let's say I was assigned the 200.1.1 address. So I would do the inside local is the private, the 192.168. The inside global is what I'm going to translate it to, which will be the 200.1.1.1, that public address to go over the internet. Dynamic NAT will create an access list to specify which addresses should be translated. So these would be all my internal addresses with the ACL number, usually a standard number, permit, and then the addresses I'm going to translate, and the wildcard. We've got to go ahead and create the pool then. So here's the access list is, okay, what's my interesting traffic? What IP address should I see that then I want to go ahead and translate? Then we got to create the pool. What is it we want to translate them to? These are the pool of addresses that you were given probably by your service provider. IPNAT pool, give it a name. Then you specify the start address, the end address, the keyword NAT mask, and the subnet mask of that. And lastly, you enable dynamic NAT by linking these two together. So IPNAT inside source list, my ACL number from up here. Okay, what traffic is going to be translated? The keyword pool, the name of my pool from this command, right there. So what traffic is going to be translated? What's it going to be translated to? And lastly, dynamic NAT is completely similar. Dynamic NAT PAT, or port address translation, also called NAT overload, is very similar to dynamic NAT. The main difference is we'll use the keyword overload. Okay. Also, I would say too, although in we're going to use a pool and a pool name, we're just going to use a small pool, you could also use an interface, which is likely probably what a lot of us do in our homes. You know, we would overload to that router interface that got an IP address, a public one, from our ISP. So, but we're going to use our pool. We're going to use a small pool, and we'll just tell it to go ahead and overload it. So when it runs out of addresses, which it won't, because it keeps track of the port, which we'll see when we do a show IP NAT translation. So let's go ahead and look at the topology that we're going to use. Pretty basic topology, right? We've got our headquarters router, which will be our edge router connected to our service provider. We have our internal network that has 4 hosts on it. And then we have, just for the purpose of testing, I have my little cloud here, okay? We pretend like this is the internet. Out in this cloud, there's some web server somewhere that I want to go to. All right? That's what we're going to use. So here's our, if we look at this, this is going to be our inside. This is our outside. And what I've done a couple things to simulate this rather than setting all this up. I've got this set up in Cisco's Viral. I really like that. It works well. And one of the things I've done is I've made this guy here, he's actually a router that has HTTP enabled. So we're also going to ping, telnet, and HTTP into it. Okay. And then over here, my actual topology is a router with the command no IP routing configured, so it acts just like a host. So we'll ping and telnet from him. Here I actually have a virtual machine connected in. And so we'll go ahead. He's going to be our one that's going to send our HTTP request over to our web server. So just what I want to see with the different, I'm using different protocols here, Telnet, HTTP, ICMP, just so you can see how NAT keeps track of those port numbers. And then these guys down here are actually additional routers with the no IP routing command enabled so that we can go ahead and ping and telnet. So this is what our topology looks like. This interface here will get our NAT or IPNAT inside command. This interface here gets our IPNAT outside command. And let's go ahead and see how it works. We'll go through the verification. So I'm going to start with, this is my edge router, right? So he's the router that I'm going to configure with NAT. And I'm going to say, okay, when any of these hosts want to leave the network, they need to be NATed. And so NAT will do its thing right here and be translated to a public address. In this case, it will be translated to something in the 201.1.1 range. So we'll go ahead and do that. I'm going to bring the console connection over for my HQ. All right, so the first thing I want to do is I want to take my first host. I'm going to do a static mapping for him. Okay, let's say he's some server on the inside of my network, and I want a one-to-one mapping. I don't want the inside global address for him to ever change. So let's look and see what his address is first, real quick. And so for this guy here, we'll do a static mapping. For the other ones, we'll do a dynamic. And then we'll take this off, we'll change it just a little bit, and we'll do overload after that. We're going to keep our static mapping on there. So with 172.16.1.10 is going to be static. So we're in our HQ router, right? First we have to define our inside and our outside networks, or interfaces, sorry. So in this configuration, gig 02 is the one facing the inside of my network, okay, or my private IP addressing space. Gig 01 is the one facing the outside, or my ISP. So if I go config t int gi0/1 IPNAT inside. Whoops. Oh, I must have old configuration on here. Let me go ahead and get rid of that. We'll come back. I'll come back. All right, so I cleared my old configs off, so that won't be an issue for us. Also, I noticed, too, that I had specified the wrong interface anyway for what I wanted to do. So int gi0/1 is the one facing my ISP, so he should be outside. IPNAT outside. We'll tab complete. And then gig 02, my gigabit 02 interface, is my inside. So IPNAT inside, he's the one facing my private network or my internal LAN. Now all we have to do, we'll exit back one and configure our static mapping. So IPNAT inside source static, the address that I want to translate, so my inside local 172.16.1.10, and the public or the inside global address that I want to translate it to is 201.1.1.10. So that's it. So how about now I go to that device, and well, first let's do a show IPNAT translation. So let's do a show IPNAT translation. And you can see that this will stay in my table. Okay, so if I do, let's exit back. Let's do a clear IP. Should have gotten rid of that. Clear IPNAT translation. Asterisk. Clear everything. We do a show IP. This stays in here because this is our static mapping. This isn't dynamic. This will always be true. 201.1.1.10 is my inside global address, and my inside local address is that host that I said I wanted to translate from. So 172.16.1.10. Now if I go to that host and I ping, we're going to see a little more information. So I'm going to do that real quick. I'm going to go ahead. I'm going to go ahead and just try to ping. I'll go ahead and I'll try to ping this web server right away. And double check connectivity first, so we might have to do some troubleshooting. But I'm going to go ahead and I'm going to ping the 200.1.1.5 address. So we're back in HQ. We're going to leave our static NAT alone because static and dynamic will work together. In fact, we probably want it to. So first thing we got to do is create our access list that will specify which traffic is going to be translated, or which traffic will use NAT. So access list 1 permit. I'm just going to list all my internal hosts for this. Whoops. 172.16.1.0. Okay, and then the wildcard mask. So access list 1 permit my network and my wildcard mask. Now I've got to go ahead and create my pool. These would be the public addresses that you've been assigned. So IP NAT pool, give it a name. We'll just call it NAT1. And the address pool range is 201. My start address will be 201.1.1.11. And my end address will be 201.1.1. Just 200, whatever. We'll say we got lots of hosts on the inside. We don't really, but if we were building a big network, we might. And then net mask, and the subnet mask of this group, just 255.255.255.0. Now I've got to link the two, right? I've got to make dynamic NAT work by linking the two. So IP NAT inside source list, our access list number, which is 1. Pool, and our pool name, which is NAT1. And that's it. So now what I want to do is I'm going to go ahead and I'm going to ping, and I'm going to telnet from all my hosts, and then I'm also going to go into my virtual machine, and we'll go to the web of that router that's signifying my web server over there. So I brought the PC over so you guys can see. Let's go ahead and ping 200.1.1.5, which is the router that I've configured to handle web traffic, or to be able to HTTP into it, to kind of act as our web server. So we're going to ping him first. Hopefully we have connectivity. Whew. It's the scary part about demos. Then let's go ahead and go to the web. So I've got to open up my web browser. .1.1.5, and I just have a password of test here. So you guys know you could use the local database by using on the device itself, configure username, whatever the name is, password, whatever the password is. It would have a username and password. I just have an enable password of test, and that brought me into kind of the web server of this device. So use that protocol. So now let's go back and see what our translations look like. So exit out. Hit the up arrow. Don't want to clear them. I want to actually see them, because I used the up arrow too many times. Show IP NAT translations. Awesome. Now what we can see is our communication. Here's our HTTP communication. Right? That's the port. We're going to that port. So this is the port my computer chose as the source, or my computer's using as the source, and then the destination's 80, as we know it is. So there's our translation. We have our inside global address, which is the public address, the first one in our pool that it was translated to, the device we were using, so our inside source device. So we went from, so if I even go back, which shouldn't be that hard, let's see. And we'll minimize that. Do an IP config, and you can see it's 172.16.1.11 is the address for this. So now I go back in here. We say 172.16.1.11 wants to go to 200.1.1.5, which it did. So as it goes to this address, as it hits our edge router that's doing that, this address gets changed or correlated to, the packet gets changed to 201.1.1.11. And you'll notice that it keeps track of the whole flow. Protocol we're using here is TCP. So now I just bring the console over of my other my routers that I said I've turned off IP routing, so now they're acting as hosts in my network. And I'm also going to ping this address, 200.1.1.5, and then we'll go ahead and telnet to it, assuming that's successful. I have very insecure telnet right now because I've actually turned off logging in. So you notice that it automatically went to it. Let's do the same thing over here in our other host. Now we're successful, so we're going to go ahead and telnet. All right, now let's go back to our edge device, or our HQ router. See what our NAT translation table looks like now. So we hit an up arrow. We got a mess of something, don't we? Let's do this real quick. Let's clear our terminal. And now let's do a show IP NAT translation. So now you can see some of my other addresses coming through, the 12 and the 13. They used ICMP, so we're going to use a query ID here. But then here we use telnet, and so then it had a source port, a TCP source port. If they both try to use the same one, it'll use the next available one. And then notice that our destination, or outside where we were going, is still 200.1.1.5, but the port number is 23 for telnet. So it keeps track of the whole flow. So we did static NAT, we did dynamic NAT. Now let's go ahead and do PAT, port address translation, or NAT overload. So in this case, I had enough addresses for each of my hosts, so it didn't reuse an address. When 12 wanted to go out, it used 201.1.1.12. When my host 172.16.1.13 wanted to go out, it used the next available one, which was 201.1.1.13, and it would keep doing that. Let's go back. Let me go ahead. I'm going to ping from our other host just to create another session real quick. So let's do this. So let's go ahead and ping that. And then bring up our HQ console and do a show IP NAT translations again. And so now you notice too, we're using 172.11, use 201.1.11, and it just happens to be that's what it grabbed, right? It was likely that, so these translations will automatically time out at a certain time. It was likely that this translation wasn't timed out when I went and pinged and telnetted from the other ones. So just grab the next one, grab the next one. By the time I came back through to ping from my host again, the .11 host, that address was available. So it just grabbed the first available one. And it can keep doing that if my pool's big enough. It's just going to use a new address every time. With PAT or NAT overload, we can use the same address. We can use the same address up to 65,000 times because of the number of ports we have. Okay? So let's go ahead and do that. So I think first we'll look at our running config, and we'll begin at NAT. So the first time it sees NAT, it's going to show that output to us, just to go ahead and see what we need to do differently in order to use dynamic NAT port address translation. I should say we're using dynamic NAT to use port address translation. So if I do a show run and a pipe to begin NAT, I forgot it's going to show me that interface. All right, let's do this. What translation? Probably would have been just as easy to just do a short, continuous spacebarring through, huh? What? Oh, brain work for a second, Renee. Brain work. We're doing translations. We never use that as a keyword. Oh, pool. There we go. So this is, I just wanted to see it as one simple basic group, right? Okay, so here's our dynamic and static NAT. Well, this is our static NAT. This is a couple of our dynamic NAT. Our pool needs to be smaller, right? And then here we're going to need the keyword overload. So I'm going to go ahead and get rid of both of these commands. I've got to get rid of this one first, because if I try to get rid of this one first, it's going to be, it's going to tell me that that pool is being used somewhere. So let's do a copy and paste, highlight it, copy. And yes, we want to get rid of all our dynamic mappings that are in place. And now let's go ahead and get rid of this pool because we actually want to, well, I suppose we don't have to get rid of it. We can probably just modify it. So let's just go ahead and modify it. It should let us modify it now. If not, we'll get rid of it. And let's just modify it to 2 hosts because we actually have 4 in our network. We have 1 that's statically assigned, so we have 3 that we're going to use dynamically. So if we only give it 2, then what we're demonstrating is that our pool is too small to assign a new address to every one of our hosts that will want to go on the internet simultaneously. So our new pool will be from .11 and .12. Now we've got to link this new pool that we created to the access list here and enable NAT overload or PAT. So we'll do an IP NAT inside source. Ooh, let's get this out of your way. Static. Sorry, not static at all. Wow. Source list. Our list number is 1, our access list, and our pool is NAT1. And we'll use the keyword overload to tell it that it's using PAT, basically, and that it can reuse that address and pay attention to that whole flow. Now if we hit enter. Now I'm going to go back through and I'm going to do the pings and the telnets and things like that, and we'll generate some translations and we'll look at our table again. So I pull this up. Ah, 200, sorry. 200.1.1.5. My ping's going to time out by the time I do this, knowing me. We'll put our address, or not our address, our password in there. So now we should have an HTTP translation. And then we will go over to our other devices. We'll ping and telnet again. So now we will have used 3 devices, but we only have a pool for 2, right? And then it's as simple as that. We did the configuration. We generated traffic just to verify the configuration. So if we do a do show IP NAT translation, now what we can see is that we're using the same address every time. And it could do this until it exhausts the number before it uses the next one. And like I said, it's up to 65,000. It doesn't necessarily have to use 11 and then use 12 and then use 11 and then use 12. As you can see here, it translated all of them to 201.1.1.11. And because it keeps track of the source and the destination ports and the addresses all the way through, they're all unique. And if a source port isn't available, it'll just use the next one, right? So if it's not, if they both want to use 1109, but 1109 is already being used, then we use 1110 and 1111 and so on. So there you go. That's pretty much it. And the big thing to notice with PAT is that we're using the same address. With our NAT, it's all NAT. I'm sorry. With dynamic NAT, without overload, without port address translation, it used the next address each time. So if I had 200 hosts, I need to have 200 addresses. With PAT, it can use the same address over and over and over again. All right, that's it. I hope that helped explain it a little bit for you.